And the square root property says if you have a squared is equal to c, then if you want to solve for a, now for a squared, you have to take the square root of both sides. The side that's not squared has to sprout that plus or minus, right? So it says if a squared is equal to c, then a is equal to plus or minus square root of c. So here is an example. So let's say we have 2x squared minus 6 is equal to 0, right? And we want to use the square root property. Now here again, in order to use this square root property, you have to have a certain form. And the certain form you have to have is your squared term and your constant. So in this case, we have a squared term, 2x squared, and we have a constant. In order to use the square root property, we have to isolate for our squared term. So in order to isolate for the squared term, I'm going to add 6 to both sides. Right, or I'm going to transpose 6. And I want to solve for x squared, not for x. So the coefficient of your squared term must be 1. So I'm going to divide both sides by 2. Right, so 6 divided by 2 is 3. And now I can apply the square root property. So if I square x squared, that's simply going to return x. The side that's not squared has to sprout that plus or minus. Right? So the solution here would be x is equal to plus or minus 3. So now you actually have to use that when you use that complete the square method. So let's see, our problem was, this was number 7. 3.2, number 7. And we want to complete the square. Y squared plus 4y is equal to 5. All right, so in order to complete the square, you have to have a certain form. And a certain form you must have is you must have the squared term and you must have the first degree term. So when I say squared term, that's just whatever your variable is squared. And the coefficient of your squared term must be a 1. So I have the coefficient squared, the first term is 1, and I have my first degree term, which is just your variable raised to the first power. So both of those things must be on the side of your equation together. Okay. So this is the correct form that I have. To complete the square, once you have your proper form, right, your squared term, which has to have a coefficient of 1, and your first degree term on the same side of your equation together, you take half the coefficient of the middle term squared. So if I take a look at my left-hand side, the coefficient of my middle term is 4. So I'm going to take half the coefficient of the middle term. So I'm going to divide that 4 by 2. And then I'm going to square it. So 4 divided by 2 is 4. Excuse me, 4 divided by 2 is 2. And 2 squared is 4. Now here's one, not really a catch to this, but you got to be careful. Whatever you do to one side, you must do the exact same thing to the other side. So since I've added 4, once I completed the square on my left-hand side, I added 4 to my left-hand side. I must also add that same quantity to my right-hand side. Right. So I added that same quantity to my right-hand side. Whenever you complete the square, you have what are called perfect square trinomials. So that means that y squared plus 4y plus 4 can actually be written as a perfect square trinomial, right? So I can take y squared plus 4y plus 4, and I can actually write that as y plus 2 quantity square. So now here's where that 2 comes from. The 2 comes from whatever half of the middle term of your coefficient is. That's the magic number you use to rewrite that trinomial factor. Right? So I have y plus 2 quantity square, and 5 plus 4 is 9. Now I can use the square root property. So if I take the square root of the left-hand side, the square root and the square cancel. On the right-hand side, that now becomes plus or minus the square root of 9. So simplifying, we have y plus 2 is equal to plus or minus 3, because the square root of 9 is 3. And now in order to solve for y, I can transpose or move 2 to the other side of my equation. So this now becomes y is equal to negative 2 plus or minus 3. And then here's my two answers. Y can equal to negative 2 plus 3 or negative 2 minus 3. So negative 2 plus 3 is 1, and negative 2 minus 3 is negative 5. So my two solutions are 1 and negative 5. Now, as I kind of alluded to earlier, even though the directions may tell you to do it one way, you could actually factor this. If you were to put it in standard form, make it equal to 0. So here's another method. Right, y squared plus 4y minus 5 equal to 0. Then I could factor, I can make two sets of parentheses. I could put y in the front of both. Right, I can determine my signs. If the last term is negative, it doesn't matter what the sign of your middle sign is. One of those numbers is positive. One of those numbers has to be negative. I can use the product sum. Right, my product should equal to the last term in my trinomial, which is negative 5. My sum should equal to the coefficient of my middle term, which is 4. So I need two numbers. When I multiply them, I get -5, but when I add them, I get -4. One has to be positive. One has to be negative, so I can use 5 and -1, right? Because 5 times -1 is 5. 5 plus -1 is 4. So I can write out my factors as y plus 5 times y minus 1 equal to 0. I can use the zero factor property. I can take each factor, set it equal to 0. And if I solve them, y is going to equal to 5 and y is going to equal to 1. So we get, excuse me, y is equal to -5, right? Because I transpose +5 across the equal sign. And that gives me my two solutions, -5 and 1. And just to show, it really doesn't matter which method you use. You can even use the quadratic formula. Okay, and I'll do that just as a review. So this will be method number 2. So in order to use the quadratic formula and the zero factor method, your equation has to be in standard form. So the quadratic formula is -b, where x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. A is going to equal the coefficient of your second degree term, which is 1. B is going to equal to the coefficient of your first degree term, which is 4. C is going to equal to the constant, which is -5. So when you're using the quadratic formula, make sure you use the coefficient as well as the sign. So then if you substitute all this stuff in, x is going to equal to -4 plus or minus 4 squared minus 4 times 1 times -5 all over 2 times 1. Alright, so x is equal to -4 plus or minus. So remember, when you're simplifying the inside of that square root, you're using the order operations. Please excuse my dear Aunt Sally. The first thing we're going to do is evaluate the exponent. So 4 squared is 16. Next, we're going to multiply. -4 times 1 is -4. -4 times -5 is +20. Divided by 2. All right, so we're going to keep simplifying the innermost parentheses. So 16 plus 20 is 36. The square root of 36 is 6. So when I simplify this particular fraction, I want to use that divide by monomial rule, where it says that you should treat the denominator as a denominator of every term in the numerator. I'm going to write this as negative 4 over 2 plus or minus 6 over 2. So negative 4 divided by 2 is negative 2 plus or minus 3. And then if we split it up like we did in the first, we get those same answers, negative 5 and positive 1. All right, so those were all three methods. Okay, the completing the square is very rarely used. All right. So moving forward, and this is still in section, the same section, we're going to talk about discriminants. And for a discriminant, it says given the quadratic equation, y is equal to ax squared plus bx plus c. So keep in mind that the quadratic equation is in standard form. The discriminant, which is capital D, is equal to b squared minus 4ac. So that b squared minus 4ac is actually what's inside of the radical. But it's without the radical. It's just b squared minus 4ac. This can tell us how many roots or how many solutions an equation has. So a root, that's the same thing as an x-intercept, and that's the same thing as a solution. So all three of those words are interchangeable. Now you're going to see real roots and imaginary roots. So what is a real root and what is an imaginary root? Now when you're, and I'm going to pull up the graphing calculator just for a visual. So I'm just going to graph a couple of equations. So let's say if I graph x squared, just clean this out, x squared minus 4. And if I just graph, notice that this graph has two real zeros. Right? So it hits the x-axis in two spots. Right? If I were to solve x squared minus 4, I'll kind of do that over here. X squared minus 4 equal to 0. I could use that square root property, so I could add 4 to both sides. Now I can take the square root of both sides, x equal to plus or minus square root of 4. So x is equal to negative 2 and positive 2. The negative 2 and positive 2 are where your graph hits the x-axis. Here's what an imaginary root is. Let's say I have x squared plus 4 equals 0. And then let's just say we were using the square root property, so we have x squared is equal to negative 4. I'm going to take the square root of both sides. X is equal to plus or minus the square root of negative 4. X is going to equal to plus or minus 2i. So notice, and we don't deal with imaginary roots when you're solving these equations, but notice this I kind of pops its head up because in complex numbers, we treat the square root of negative 1 as I. But if I were to graph that, x squared plus 4, notice that the graph does not touch the x-axis at all. And then we can have other equations that only touch the x-axis once. So let's see, x squared plus 6x plus 9. Right? If I were to grab x squared plus 6x plus 9, notice it only touches the x-axis at one place. So that would be an example of one real solution. We can use this discriminant to tell how many real solutions there are before we actually calculate anything. So here are some examples of that discriminant. Okay, and this is number 15. This should be similar to your number 15, 3.2, number 15. We're asked to find the discriminant. So the equation is a squared minus 8a plus 7. And we're just asked to find the discriminant. All right, so we're going to use the formula d, which is the discriminant, is equal to b squared minus 4 times a times c. So notice there is no square root in that discriminant. So just like when we were using a quadratic formula, we're going to pull out the coefficients. So a, that's going to be the coefficient of your squared term. B is the coefficient of your first degree term. So remember, you have to take the number as well as its sign. And then C is your constant. So I'm just going to dump all of this stuff into the discriminant formula. So that's negative 8 squared minus 4 times 1 times 7. Negative 8 squared is 64. Negative 4 times 1 is negative 4. Negative 4 times 7 is negative 28. 64 minus 28 is a positive 36. If your discriminant is positive, right, you should have two distinct roots. If the discriminant is 0, right, once you calculate b squared minus 4ac, if it's 0, then it has one real root. And if your discriminant is negative, it has no real roots. Since this discriminant is positive, it has two real roots. Because the question asks you for what's the discriminant, and it asks you how many roots it has. And we'll take a look at another one. This is similar to your problem number 14. (3.214). Find the discriminant. X squared minus 2x plus 4 equal to 0. Right, so I'm going to do the same thing. I'm going to write out the discriminant formula. That's equal to b squared minus 4ac. A is going to equal to 1. B is equal to negative 2. And C is equal to positive 4. And I'm just going to substitute into the formula. So D is equal to negative 2 squared minus 4 times A, which is 1, times C, which is 4. All right, so remember the order operations. Please excuse my dear Aunt Sally. So we're going to evaluate the exponent first. So negative 2 squared is 4. Next, we're going to multiply negative 4 times 1 times positive 4 should give us negative 16. 4 minus 16 is negative 12. Right, so since our discriminant is negative, it has no real roots. All right, so for those problems, they simply want the discriminant and how many roots it has. All right. So that kind of wraps up 3.2. In the next section, 3.3, there are a couple of things. First, there is absolute value. And on top of absolute value, there is something called interval notation. So I want to talk about interval notation first. All right, so we have what's called open intervals and we have closed intervals. And these other intervals are like half open and half closed. I'm going to explain all of that. So now here's how it breaks down. When we answer a absolute value equation, there is more than one answer. We can write out more than one answer in what's called an interval. So if we take a look at these one at a time, right? So this first set says open interval. So now this is how you actually read this. This says all real numbers x such that x is greater than a. You can graph that, right? So greater than means all the numbers bigger than a. We can write that in interval notation as a comma infinity. We can also have what's called a compound interval. So this is read as a is less than x is less than b. So that means that the value for x has to be in between a and in between b. And then we have this last open interval that says x is less than b. You can write that as negative infinity comma b. All right, now some of these things we don't deal with, like, well, I guess we do deal with it. Well, we're going to take a look at some examples using real numbers. So I'm going to write the inequality we're going to make a rough sketch of a graph, and then we're going to convert that rough sketch of a graph into interval notation. So let's take the first one. X is greater than 3. So let's just say we get x is greater than 3 as an answer. They want us to answer the interval notation. So I'm going to make a rough sketch of a graph. Right? So when we make a rough sketch of a graph, I'm just going to center it at 3. To the left, you have this arrowhead, right? That means that this graph keeps on going and going and going. The number gets smaller, smaller, smaller. This is represented by negative infinity. To the right, there's another arrowhead, which means that this line keeps on going forever, and it gets bigger and bigger and bigger and bigger and bigger. that's represented by positive infinity. So it's like a sideways 8. So now if we were using open circles and closed circles, if you do not see this equal to bar, then you would use an open circle, right? So I'll use an open circle. But since we're dealing with inequalities, the open circles are replaced by parentheses, a set of parentheses. So now if I would be graphing this, I would just put a circle and I would just put my line going to the right. Well, I would put an open circle, right? And then the line would extend toward the right. Since we're using interval notation, at 3 I'm going to put a parenthesis, but I'm going to face that parenthesis toward the right. So instead of using open circles, we use parentheses. And instead of using closed circles, we're going to use brackets. So since this is it doesn't have an equal to bar, I'm going to use an open circle, which in this case is a parenthesis. That parenthesis is going to face the right. My line is going to extend to the right because those are all numbers greater than 3. To write that out as an inequality, that's going to be based on the graph that I see. So to write x is greater than 3 as an inequality, I'm going to put a parenthesis. I'm going to put 3, comma, infinity with the end parenthesis. You never close off an infinity symbol with a bracket. You always use a parenthesis. All right, so we've converted the inequality to an interval. Let's look at x is greater than or equal to positive 3. Okay, same thing, I'm just changing up the inequality. So here again, I'm going to make a rough sketch of a graph. So I'm going to center the graph at 3. I'm going to put negative infinity to the left always, positive infinity to the right always. So now this time we have the equal to bar. And if we were using open circles and closed circles, we would use a closed circle. Since we're going to convert the graph to an interval notation, instead of a closed circle, I'm going to use a bracket. So a bracket and a closed circle have the same purpose. That bracket is going to face the right. Since I want all numbers that are greater than 3, my line is still going to face the right. So I'm going to write this in interval notation as bracket 3 to infinity. All right, so that rough sketch of the graph, that basically is your interval notation. All right. So next I'm going to write x is less than 3. So we're going to make a rough sketch of a graph, and then we're going to take that rough sketch of a graph and write it in interval notation. So here again, no need for an elaborate graph. All right, I'm just going to make a basic line graph centered at 3, negative infinity to the left, positive infinity to the right. So we want all numbers less than 3. So at 3, I'm going to have a parenthesis, but this time the parenthesis is going to face the left because I want all numbers smaller than 3. My line is going to extend to the left. So now you want to remember, whenever you write out these interval notations, they must always follow a number line from left to right. So when I convert x is less than 3 to interval notation, I'm going to write basically what I see here on my graph. I want to put a parenthesis, negative infinity to positive 3, with the in parentheses. So notice if you look at your interval notations, the smallest number always is on the left. Your biggest number or your biggest quantity is always on the right. All right, so let's take a look at x is less than or equal to 3. All right, so I'm just kind of picking on 3 just to keep it all the same. All right, so I make a rough sketch centered at 3. I want all numbers less than or equal to 3. So at 3, I want to use a bracket that faces the left. My line extends to the left. And I'm going to just write that as interval notation. So it's an open parenthesis, negative infinity to 3 with a bracket. Right, so any questions about this single inequality? Right, so we're not using open circles, closed circles, we're using parentheses and brackets. Now let's look at some compound inequalities. So let's see, 2 is less than x is less than 5. So how would you write 2 is less than x is less than 5 in interval notation? Well, we're going to do the same thing. We're going to make a rough sketch of a graph. In this case, I'm going to center the graph at 2 and 5. Right, because I have 2 numbers instead of 1 number. And I'm still going to put negative infinity to the left and positive infinity to the right. Okay, now normally when we write out inequalities, the variable is normally on the left-hand side. If the variable is on the left-hand side, you can use which way that inequality is pointing to tell you which way your line is going. So like if you look at the first one, that inequality is pointing to the right and my line is going to the right. Same thing for the second one. My inequality is pointing to the right, my line is going to the right. And then for the last two, my inequality is pointing toward the left and my line is going toward the left. So when you look at this compound inequality, it's actually telling us two things at the same time. It's telling us that x is less than 5, right? So that means at 5, I would have a parenthesis that faces the left, and my line is going to extend to the left. Right? That's because the variable is on the left-hand side. But if I look at the first part, it says 2 is less than x. So for the first part of this inequality, my variable is on the right. You can actually rewrite that. So when I rewrite it, I want to flip it over, which means I want to flip the inequality in everything. So 2 is less than x can actually be written as x is greater than 2. So when I look at my inequality, notice that the inequality is opening up toward x. When I rewrite it or flip it over, that inequality should still open up toward x. So 2 is less than x is the same thing as saying x is greater than 2. So now since my variable is on the left, I want all numbers that are greater than 2. So at 2, I'm going to use a parenthesis that faces the right. My line is going to extend toward the right. And I'm going to write this as 2, 5 in interval notation. And then the last example is sometimes you're going to see inequalities that look like this. Right? So this is also a compound inequality, but this is what's called a disjoint, which means that when you graph this inequality, you're going to have two separate inequalities. They're going to be separate or disjointed from each other. All right, so in order to write this in interval notation, I'm going to make a rough sketch of the graph. I'm going to center it at -2 and +2. Negative infinity is to the left, positive infinity is to the right. So now both of my excuse me, variables on the left-hand side. So x is less than -2. At -2, I'm going to draw a parenthesis that faces the left. My line is going to extend to the left. Excuse me. Or x is greater than 2. So at +2, I'm going to have a parenthesis that faces the right. My line is going to extend to the right. Right? So this is what's called a disjoint interval because they're separated. Now, when I write that in interval notation, keep in mind that your interval notation still has to follow a number line from left to right. So I'm going to write this part of my interval first. So that's comma negative infinity to -2. Between those, I'm going to put a union. This is a union, and it's used for disjoint sets. And then I'm going to put in my other interval. So that's 2 to infinity. All right, so if we're given an inequality that looks like this, we can convert it to interval notation, and it must be written in this way. Right? It has to follow a number line from left to right. All right, so that is interval notation. Now here's where this comes in. We're going to solve some inequalities. We're going to get inequalities in the answer, and they want the answers as interval notation. All right. So now these formulas may be a little bit complicated, but this case 1, this is to solve an absolute value equation, right? Because an equation is anything with an equal sign. So I'm going to just kind of shorten these up a little bit. So case 1 says if the absolute value of A is equal to C, then solve A is equal to C or A is equal to -C. Okay, so this is case 1. And there are quite a few things in this first equation that are like understood. So first off, you must isolate for your absolute value, which means that the only thing on the side of your absolute value before you can use this formula should only be the absolute value. If the absolute value has something added to it or subtracted from it, you have to transpose those things to the other side, and then you can apply this formula. So here is an example. Three times the absolute value of x plus 1 is equal to 5. Was equal to 6, I'm sorry. So 3 times the absolute value of x plus 1 is equal to 6. Before I can even apply this absolute value formula, I have to make sure that this absolute value is isolated. So that means that this 3, I got to move it to the other side. So the opposite of multiplying the absolute value of x plus 1 by 3 is to divide by 3. So the first thing is to isolate the absolute value. So we're going to divide both sides by 3. So 3 times the absolute value of x plus 1, that gets divided by 3. And 6 gets divided by 3. So on the left-hand side, my 3's cancel. And I'm left with the absolute value of x plus 1, which is what I want. And then 6 divided by 3 is 2. So now I have the right form. So this formula says that if we have the absolute value of A is equal to C, then you can drop your absolute value and you can set your A equal to C, or you can drop your absolute value and set it equal to a negative. So notice I isolated the absolute value, and then I set it equal to a positive, and then I set it equal to a negative. So now I want to solve them. All right, so these are just linear equations. So x plus 1 equal to 2. I'm going to transpose positive 1 to both sides, which means I'm going to subtract 1 from both sides. So I have x equal to 1. Or I'm going to transpose 1 for that second equation, or subtract 1. So that means x is equal to negative 3. Right? So x can equal to positive 1 or negative 3. Just to take a look at one more. This is similar to your number 2, 3.3 number 2. It says the absolute value of 2x plus 3/4 is equal to 4. So the absolute value is isolated. I mean, the only thing that's on the side of the absolute value is the absolute value. So I'm going to use the formula. I'm going to drop the absolute value. I'm going to set it equal to a positive. And then I'm going to drop the absolute value and set it equal to a negative. All right, so when we were solving linear equations, there were 6 steps. The first step says remove the fraction. So the first thing I'm going to do here is move the fraction. You remove the fraction by multiplying both sides by the least common denominator. So there's only one denominator here, which is 4. So I'm going to multiply both sides by 4. So 4 is multiplied by the left-hand side and the right-hand side. So this should automatically remove any parentheses, any fractions that we have. So when you multiply 4 times 2x, you get 8x. When you multiply 4 by 3/4, the 4's are going to cancel, and that's going to leave 3. So whatever you do to one side, you do the same thing to the other. So we're going to multiply 4 on the other side. So now I just want to solve it for x. All right, so I'm going to subtract 3 from both sides. I'm going to divide by 8, so x is equal to 13 over 8. I'm going to do the same thing to the other equation. All right, the least common denominator is 4. I'm going to multiply both sides by 4. So on the right-hand side, we're going to distribute 4. 4 times 2x is 8x. 4 times 3/4 is 3. That equals to negative 16. All right, I want to solve for x. So the first thing I'm going to do is transpose 3 to the other side. So that means I'm going to move it across the equal sign and make it a negative. So negative 16 minus 3 is negative 19. I'm going to divide by 8, so x is equal to negative 19 over 8. Right, so I just got two answers, 13 over 8 and negative 19 over 8. Any questions about that absolute value equation? Now this is where the inequality stuff comes in, and the interval notation is with the second two formulas. So here is case 2, and I'm going to call this one case 2. So it says if the absolute value of A is less than C, then negative C is less than A is less than positive C. So this was kind of taking some turns. So if you have the absolute value less than, and this formula applies for less than or less than equal to. So if it were like a less than equal to, that equal to bar would just travel along in the formula. Okay. But generally when you see it written, it's written without the equal to bars. All right, so here is an example. And this should be similar to your problem number 9. The absolute value of x plus 1 is less than 5. All right, so here again, there are some understood things about this formula, right? First off, the absolute value still has to be on the same side of the equation by itself. And we're looking at a less than. So this formula is going to allow me to write this as, so just keep in mind that in the formula, A is everything inside the absolute value. C in this case is going to be 5. So that means I can write this out as negative C, or negative 5, is less than A. So remember, A is what's inside of the absolute value, so that's x plus 1, is less than positive 5. Right, so I'm just using this formula. I'm substituting A for whatever is inside of the absolute value, and I'm substituting C for 5. So now this is a compound inequality, and we want to work it from the inside out. The only thing we want on the inside of these inequalities is x. So I'm going to have to take positive 1, and I'm going to have to transpose it or subtract it from all three sides of this inequality. So I'm going to have to subtract 1 from the left-hand side. I'm going to have to subtract 1 from the middle. And I'm going to have to subtract 1 from the right-hand side. Right, whatever you do to one side, you have to do the same thing to all sides. Right? So if I look at my leftmost side, negative 5 minus 1 is 6, is less than, in the inside, the 1's cancel, I'm left with x. And on the right-hand side, I'm going to bring down my less than. 5 minus 1 is 4. But here is the kicker. They don't want it written in this form. They want it written in interval notation. So I'm going to make a rough sketch of a graph. And this should be negative 6, excuse me. Negative 5 minus 1 is negative 6. So I'm going to put negative 6 to the leftmost, 4 to the rightmost. Negative infinity goes to the left, positive infinity goes to the right. So just remember that negative 6 is less than x. That's the same thing as saying x is greater than negative 6, right? So at negative 6, I have a parenthesis that faces the right. My line also extends toward the right. And at the same time, x is less than 4. So at 4, I'm going to have a parenthesis that faces the left. My line extends to the left. So that's my interval notation. It's the open interval from negative 6 to 4. So those absolute value inequality problems must be answered in interval notation. And there's also a third formula. So this would be case number 3. It says that if the absolute value of x is greater than, the absolute value of a is greater than c, then a is less than negative c, or a is greater than positive c. All right, and here is an example. The absolute value of x minus 9 is greater than 1. Okay. And this is similar to one of the problems in the homework set, but I just didn't write it down, the problem. All right, so this is the absolute value of x minus 9 is greater than 1. So I'm going to use the formula, and I'm going to rewrite this as x minus 9 is less than negative 1. So notice I flipped my sign, and I've rewritten 1 as a negative 1. So just keep in mind that in this formula, a is whatever is inside of your absolute value. And then for this case, c is going to be 1. So the formula says I reverse my inequality. I'm going to make 1 negative. Or I can drop the absolute value, keep my sign, and keep 1 exactly the same as I see it in the problem. So now we're going to solve them. So to solve this first inequality, I'm going to transpose 9 or add 9 to both sides. So x is less than 8 because 9 minus 1 is 8. Or if I add 1, or if I add 9 to both sides here, 9 plus 1 is 10, so x is greater than 10. So we want to write this in interval notation. So we're going to make a rough sketch of a graph. We're going to center it at 8 and 10. X, okay, I'm going to put negative infinity to the left, positive infinity to the right. So x is less than 8. So at 8, I'm going to have a parenthesis that faces the left. My line is going to extend to the left. I'm going to grab x is greater than 10. So I have a parenthesis at 10 that faces the right. My line is going to extend to the right. So now I want to write that in interval notation. So I'm going to write it as negative infinity to 8 union 10 to positive infinity. All right, so that's the interval notation solution.